Okay, so your next chapter, chapter 1, is on solving equations. Sorry if that's bothering you, I can't get it to go away. I guess we'll just start it down here out of the way. Okay, chapter 1 is on solving equations. We're skipping section 1.1 because it doesn't have equations. It's like this random graphing section. Anyway, we will talk about graphing, but not in chapter 1. So the rest of chapter 1 is all about solving different types of equations. So section 1, 2 is linear equations and rational equations. So today we're going to talk about linear equations, and we're going to stick with one variable for now. So we are going to take basic equations, I guess, and solve them. So remember that when you're solving an equation, you're figuring out what the variable equals, like a value for the variable that makes it a true statement. And it can sometimes be called solutions, sometimes they're called roots. If we were talking about graphs, they'd be called the x-intercepts. With linear, you're only going to have one answer. But if you are solving something like a quadratic and you get more than one answer, then a solution set is just a set of answers. So if I solve an equation and I get 2. When I look it up in the back of the book, they might write it as the solution set. If I solve an equation and I get that x is 3 and x is 4, then when I look it up in the back of the book, they're going to write it like that. So I don't need you to be fancy and write it. I just need to know what x equals. Just know if you're trying to check answers in the back of the book, that's what it's going to say. All right, and then equivalent equations are 2 or more equations that have the same solution set. So just equations that are equal. All right, so out of all of this, what you really should probably make sure that you have written down is this, in case you get lost in the process of solving, you need to look at some steps. All right, so pause and write that down. So, to solve an equation, we are trying to get x by itself. So if you have something nice and simple like this, remember you do the opposite of what's there. So this plus 5 needs to go away, so we're going to subtract 5. Now we need this times 4 to go away, so we're going to divide by 4. And what you do to one side of an equation, you have to do to the other to keep everything nice and balanced. Alright, so that's number 1. Number 2, you see that there's parentheses. Well, we need those to go away, so we're going to distribute to make the parentheses go away. We haven't done anything with that 29 yet, so he just hangs out. Alright, so now you look at the left side. Are there any like terms? No. Look at the right side. Do we have like terms? Yes, we can put 29 minus 5 together and get 24. And remember that if you're not moving across the equal sign, you do exactly what it says, 29 minus 5. Alright, at this point, you're trying to get variables on one side, numbers on the other. I usually pick the smallest variable and move it. It doesn't matter though. At this point, you can pick any of these 4 things and do the opposite, and you're going to be fine. Alright, so I'm going to pick subtract 6x because I want it to disappear over here and appear on this side but combine with the x that's already there. Alright, now we have something like number 1. So we're going to, let me rewrite it to make sure that we're all okay. We're going to subtract 4, which gives us 20. And then we divide by the 2, so x is 10. Alright, so example 3. Same thing, you have parentheses, you've got to get rid of them. Pay attention, this is a negative 1 that you're going to distribute. So 5x hangs out. We get negative 2x minus 2. Keep the x. There's nothing here, so those parentheses can just go away. Or you can think there's an understood 1 that you need to distribute. Either way, it looks like this. Alright, so on the left side, we have some x's we can combine. On the right side, we also have some x's that we can combine. Alright, now you want to get your x's on the same side. Y'all tend to like your x's to be on this side. And that's fine, so you can subtract 4x. I prefer to not give myself an extra step. If I subtract 4x, I'm going to get negative x, which is going to cause me to have to divide by negative at the end. So I'm going to subtract 3x so that I have a positive 1x minus 5. And then on this side, these cancel, and I just have negative 2. So now we're going to add 5. And x is 3. Alright, so on the next slide, I want you to pause, work these 3 questions, and then check and see how you did. Alright, so number 7. You are going to add 5. Divide by 7, and you have 11. On number 2, you have a negative that needs distributed. So think of it as negative 1 times base. So 11x comes down. This is negative 6x and positive 5 now. Keep your equals 40. All right, on the left side, you can do 11x minus 6x and get 5x. Subtract the 5. Divide by the 5. And you get 7. Alright, number 3. Again, you have parentheses that you need to get rid of, so distribute the 3. Keep up with the 7. Distribute the 2. We have some like terms we can combine on the left side. We want variables on the same side, so I'm going to subtract the 2x. So this is x plus 1 equals 10. Subtract 1, and x is 9. Alright, so when you're solving an equation, sometimes your variables disappear and you get infinitely many or no solution. Well, we're going to learn some other words for those things that you may or may not have heard before. So, if you have an equation that's true for all numbers, that means your variables disappear and you get something like 9 is equal to 9. That means it is an identity. Alright, so if you get infinite solutions, your variables disappear, they add to 0, they go away, and you get a true statement. You have infinite solutions. That's considered an identity. An equation that is not an identity but is true for at least one real number is going to be conditional. Well, that's if you work it out and you get x is equal to 2. Or you get x is equal to 2 and x is equal to 7. Which doesn't happen in this lesson, but it will in later lessons. Those are considered conditional. So everything that we've solved up to this point today is conditional. All right, and the last one, if it's not true for any number, then you have no solution. This fancy little symbol that means the empty set means no solution. You know you have no solution if your variables disappear, but you get a not true statement, like something like minus 7. You know, that's not true, so that's called inconsistent. Alright, so here's our example. They give us an equation. All they want us to do is solve it, and then decide which one of those 3 categories it falls into. Alright, so if I solve, we are going to distribute the 4, combine like terms, so on the left we don't have any. On the right, we can put the numbers together. At this point, if you recognize that your variables match but your numbers don't, you can stop and say no solution. The next step, though, is subtract 4x on both sides, and then you realize, oh man, there's no more x's. So negative 7 equals negative 1. But no, negative 7 does not equal negative 1. So this is no solution, so you can write that symbol. You can write no solution, whichever one makes you happy. But what's new is that we need to now put it in a category. So because there is no solution, it is considered inconsistent. Alright, so again, pause the video, try these 3, and then unpause and see how you did. Alright, so number 1, distribute the 2. You want your x's on the same side. You get 2 is equal to 3. Nope, 2 is not equal to 3. No solution, inconsistent. Alright, number 2. You need to distribute the -2. You need to, on this side, just combine some like terms. And this side also has some like terms. At this point, if you realize that they're literally identical, then you know it's infinitely many and an identity. But if not, if you add 2x to both sides to try to get the variables on the same side, those go away. 17 is equal to 17. That's true. So you have infinite solutions, which makes it an identity. All right, last question. Let's see, we have some like terms. We have a negative that needs to be distributed. And then again, we have some like terms. All right, at this point, you see how the variables don't match? That's your clue that you need to work it out and figure out what x is equal to, because if the variables don't match, you're going to get an answer. All right, so I added x to both sides. Now I'm going to subtract 8 on both sides. And divide by 10 on both sides. And we got an answer, which means it's conditional. All right. If you have questions, please let me know. This is the assignment. They're all odds, which means you can check your answer in the back of the book. You can look back there and see if you got the right answer. But I will give you 0 points if you do not show your work. So make sure that you show work and don't just write answers. If you have questions about anything, please let me know.